Okay, so let us discuss questions on circular motions from basic level to high level. Whatever the standard questions are there, we can discuss today. So let's start with this question. A ring rotates about z axis. So this is a ring which is rotating about z axis. The plane of rotation is xy. So ring is in the plane of xy. So axis is along z direction. Okay, at a certain instant, the acceleration of a particle p on the ring is. So some point is there on the ring, and this point has acceleration. They have given the acceleration of this point p 6 I cap minus 8 j cap. 6 I cap minus 8 j cap means 6 means in this direction 6 I cap, and 8 minus 8 j cap means downward, right? It is minus 8. Minus 8 means it is downward. Okay. Okay, I'll just write the magnitude on 8. So 8 is downward, 6 is towards right side. Okay. Find the angular acceleration of the ring and the angular velocity at that instant. The radius is given here. Radius of this ring is given. Okay, radius, let us say, is given as 2 meters. Okay. So this is a point on the ring, and this ring is like this. So definitely this is the center, right? So this is going towards the center of that. This is, let us say, center. So this acceleration which is pointing toward the center, definitely this is the centripetal acceleration. And this acceleration which is along this tangent, it is tangential acceleration. Yeah. So how to calculate angular acceleration means we have to calculate alpha and angular velocity omega. Omega also we have to calculate. Okay. At this instant. So right now particle is here at this point. Okay, calculate. Try this. So we know centripetal acceleration. I think we can start from there. Centripetal acceleration is formula is v square by radius. So centripetal acceleration is 8 v square radius they have given here too. So v square becomes 16. So v becomes 4, right? V becomes 4 meter per second. That's what we got is speed. Okay, but we want omega. So omega is v by r, that we know. We can apply omega equal to v by r. V by r we apply. So v is 4 and radius is 2. So that will become 2 radian per second. That's the answer of omega. What is alpha? How to calculate alpha? Can you tell how to calculate alpha? Hmm. Alpha. So note that this is tangential acceleration, right? This is tangential acceleration, and tangential acceleration formula is r into alpha. So tangential acceleration is 6, r is 2. So alpha we got as 3 radian per second square. Yes, tell me. Simple calculation this. Yes, I'll tell me, how did you get 10? How are you getting 10? Net acceleration. Net acceleration will be definitely 10 only because resultant of that. Right. Okay. Then let us go next. Clear? Anyone any doubt in this? You can ask. Okay, no doubt. Then we will know. A particle is performing circular motion of radius 1 meter. Its speed is given. What will be the magnitude of acceleration? Here magnitude of acceleration means resultant acceleration. Okay, so like that. So speed is definitely changing with time, so there will be tangential acceleration, right? So calculate tangential acceleration is dv by dt. This is the speed here, rate of change of speed. So 2t square, apply that. So 2 comes out, t square differentiation is 2t, so it comes 4t. And what time they are asking? At time 1 second. So time we will put it at time 1 second. Tangential acceleration 4 into 1, that is 4 meter per second square. Okay. Then magnitude of acceleration. We have to also find out centripetal acceleration also, right? Centripetal is v square by radius. V we need to calculate because radius is given as 1. Okay. Radius is given as 1. So V we have to calculate, yeah, V at that instant time is 1. So that means 2t square square. That is what it is. Radius is 1 only. So time we will substitute here. So 2 into 1 square square. So that means 2 square will become 4. This is also 4 meter per second. Okay. Then you calculate resultant acceleration, net acceleration is root under AC square plus AT square. So this is root under 4 square plus 4 square. So 4 under root 2 meter per second square. Correct? Clear. So basic level questions, but we need to be able to solve this, then only concept will become clear. Right? So let's move next. Two particles A and B start at O. Start at O. I think the diagram is not here. Okay. So this is a point somewhere here at the bottom of the circle. These two particles A and B start and travel in opposite direction along the circular path at speed where V given. Determine the time when they collide and the magnitude of acceleration of B just before this happens. Okay. So let me draw the diagram again here. So this is like a circle and two particles are starting from the same point O, but one is going this way, other is going that way. So let us take A is going in this direction. This is A and this is B. B is going. They are starting from same point. Somewhere in between it is. So it is going that way. So this is B. So their speeds are given here. The speed of A is 0.7 meter per second and speed of B they have given as 1.5 meter per second. Constant speed they are going. Okay, determine the time when they collide and the magnitude of acceleration of B just before collision. The radius is given anyway. Let's take this is the center. Center may be some other C let us take. So this radius they have given 5 meters. How will you solve? How will you think about it? See, the relative velocity in linear motion you have studied, right? You studied relative velocity, but here the velocity means we are going along circular path, so continuously their velocities are changing, right? So if you take at a given instant, you can calculate relative velocity at one instant. magnitude is changing or not, that you check. Let's say an instant. So some velocity is there. Like for example, this is VA. Let us say this is going along tangent in this direction, VA, and this tangent is along this direction, okay, VP. So let us say at an instant some angle is there. Okay. Initially the angle between them is 180 degree because this is going this way, this is going this way, right? Opposite pair. That angle is also changing, right? Continuously the angle may also be changing. So if angle is changing, then magnitude can also be changing, right? So we cannot say anything about that. Let us just think in normal case. Normal case, think we are going to collide, right? Don't make things complicated. Let us say that they are going to collide somewhere. Somewhere they collide. You take any point on the circle where they collide. Let us say that they are going to collide at this point, somewhere here or here. Anyway, this speed is larger now, so it will be covering more angle. This speed is smaller, so it will be covering less angle. So let us say somewhere this side they collide, right? They are going to collide somewhere this side onto, because it is going with a smaller speed and it is going with larger speed, so it will cover larger distance, right? So they are going to collide here. Let us say here they are going to collide. So that means this B has to rotate this much angle, right? Let us say this is theta, theta of the B, angle rotated by B, and this is the angle rotated. This is the angle rotated by A, theta A, right? And collision happens. So A will rotate this angle, B will rotate, but total sum of angle is 360 degree or 2 pi, that we know, right? Okay. Then uh, the time when they will collide, then it becomes very simple because this theta is equal to omega into t. Omega is theta by t because they are going with constant speed, right? So speed equal to distance by time. Here angular speed is angular distance by time. So we can apply simple formula here, that this theta a is equal to omega. Omega of this we do not know. Omega we can calculate because we know v and we know radius. So omega we can calculate for a, right? Omega is equal to v by r, right? V by r we can calculate. Similarly, omega of b also we can calculate v by r, vb of by r. So vb is 1.5 and radius we have given as 5. So that will become 0.3. Similarly, omega a will become how much? This is 0.7 divided by radius is 5. That we can calculate. How much will come? 0.7 by 5. 7 by 50. 7 by 50. 0.14 it will come. It will come 0.14. Okay. We got omega for each of them. Now this theta is equal to omega into t, and they have started at the same time and they are going to meet in the same interval. So time for this and time for this is same because they have started same time and they are meeting at same instant. Right. So this is omega a into time plus this will be omega b into time. Now you solve it. Time we can now solve very easily, right? Let us solve time. So from this equation, time comes as uh, uh, theta A. Sorry. This is theta A is omega at. Theta B is equal to omega bt, correct? Theta B is equal to, because this angle. So theta A plus theta B we can do now. Theta A plus theta B we do. So theta A plus theta B will be how much? Theta A plus theta B will be, this will be total 2 pi, we know that, and this theta A plus theta B will be omega A t plus omega bt. So time now you can solve, take time common and solve. So 2 pi divided by omega A plus omega b. Now we got it. Omega b already we have calculated. So solve it now. So time will be equal to 2 pi divided by omega A is 0.14, omega B is 0.3. So 2 pi divided by 0.44, and pi you can take as 22 by 7. So 22 by 7, and this is 0.44. So remove the 100 here, means decimal. 44 will get cancelled. So 100 by 7 second is the answer. Yes, that's the answer. Okay, so time we have calculated. What else they are asking? The magnitude of acceleration of b before that. B. So what is the acceleration? Acceleration. See, the acceleration is only going to be centripetal acceleration only, right? Because there is no tangential acceleration. Speeds are not changing, right? So if the speed are not changing, it is just centripetal. Centripetal acceleration is v square by radius. That we can calculate anyway, right? So for B, centripetal acceleration for B, which is v square, vb square by radius. So velocity of B already is given, I think 0.7 they have given. So 0.7 square by radius is 5. This calculation we can do, right? 7 square 49 by 100 into 5, 500 will come. So into 2 you do, so this will become 98 by 1000, correct? 98 by 1000 means 0.098 meter per second square. That's the answer. Clear? So any questions are coming in circular motion, better to think from the fundamental, because relative motion when you apply, there are different, little bit different concept in circular motion. Concept is same, but the thing is that they are going in circles, and you have to actually calculate relative angular velocity. The relative angular velocity calculations are little bit different, that we'll see after. But even if you don't know that, you can think of basic. Hmm. Hmm, hmm, hmm. Yeah, the chasing problem. One person is chasing others, right? Hmm. Yeah, but here the thing is, there it was like two, three particles are there. One particle is chasing another. Here also two particles are there, but they are not exactly chasing, but they are moving on a circular path, and they are meeting on that circular path. So they are not chasing here, right? Suppose they are not moving in circle, then they are going in different paths. So they may not collide also. It's possible, right? If they go in a different path. But here they are going, they are restricted to move in the same circle. So they are going to cross each other. So definitely here also we can apply relative, but for relative you need to understand how to do the calculation of relative velocity, right? And the two particles are moving in the same circle with different. Okay, let's think about it. Suppose two particles are moving in the, so we are taking a particular case, we are taking that two particles, two particles, two particles moving uh, opposite, opposite in the same circle, in the same circle, and starting from same point, starting from same point. That is the case here actually. So that means here they are starting from this point, and one particle is going this side, another particle is going opposite direction, right? Both are going this way. So one particle is going in this path means this way, another is going this way. This way it is going. So this is VB and this is VB. Now the thing is that they have different speeds, same radius. It is radius is same. Now suppose if you consider relative velocity here. So relative velocity, how to define relative angular velocity? That means omega of b with respect to a. How do we define this idea? Do we write? See, maybe we can think like one way, like we can think that they are going in opposite. So can we simply add them? Because opposite direction, you remember relative, we add them. Remember that omega a plus omega b. Can we simply add them? And if we add them, and suppose if you see that relative to this, one will not move, other will look like moving, and it will be hitting. So that means it has to rotate the total angle of 2 pi before it is going to hit it again, right? So if I use that concept, then I can calculate this relative angular velocity must be the total angle to hit means 2 pi divided by time. So I think this may also give, let us try that. So omega a plus omega b is equal to 2 pi by time. And this omega is v by r that we know, correct? So this is v, that was 1.5 by radius, which was 5, and this was how much? P 0.7, right? 0.7 by 5 is equal to 2 pi by T. From here also, I think the same result will come. We check that. If the same result comes, time will become 2 pi divided by. This you take LCM 5, 5 will come in the numerator, and this will get added 1.5 plus 2.2. 2.2. So when you remove 10, 10 comes in. Yeah, that's what 22 by 7, 22, 7 factor comes here, 100 by 7. Yeah, this concept we can apply. If the bodies are going in this way, we can apply this concept, right? Okay. Hmm, hmm. This one, huh? This one, huh? No, this is simple formula, huh? Like omega is equal to theta by t. This is what you are using because it's a constant speed now. So because relative to this body is going and coming after one revolution, then only it will hit it because one body is not moving, other is moving. That's what that theta we are taking as 2 pi. I think if we are starting different. Suppose let us say this body is here and this body. Initially there is some separation of alpha. Let us say, and let us say that they are going. This is going this way and this is going this way. Omega A, omega B. Now here, if you see relative to this, so relative to this means what will happen? This will be at rest now, and B will be moving with the angular velocity of omega A plus omega B, right? And it has to cover how much angle? It has to cover this much angle. This much angle will be 2 pi minus alpha, correct? Right? So then time is equal to this time will be this divided by this. So in this case formula can be time is equal to this angle 2 pi minus alpha divided by omega A plus omega B. Right? We can apply this. Previously it was 2 pi, but because alpha was 0 previously, right? So this we can apply, I think. So this can be now general, but whenever you are generalizing, you have to be careful. You need to be careful because if because this is this is a circular motion, right? Uh, we cannot always generalize. Mm. We have to better if any confusion is there, better we can go with normal that they are going to collide and it won't take much step. It also doesn't take more steps, right? We can solve that. Okay, then let us go next. Try this question. Particle is moving in a circular orbit with a constant tangential acceleration. After a certain time t has elapsed, after the beginning of motion, the angle between the total acceleration a and the direction along the radius r becomes equal to 45 degrees. What is the angular acceleration? What this question says, the particle is moving in a circular orbit with constant radius. So tangential acceleration is constant here. This is constant. Okay. After certain time has elapsed after the beginning of motion, angle between the total acceleration and direction along the radius r becomes equal to 45 degrees. Okay, so let us draw a circle. Let us say that it has started here. This is the, let us say, x-axis. This is y-axis, and this motion has started here, time 0. So time 0, particle moving in constant position after certain time elapsed after the beginning of motion. Beginning of motion means initial, you can see it has initial angular velocity 0, everything is 0 because initially it was at rest. So after some time they are saying that the total acceleration and the direction along the radius angle between total acceleration. So you know that at any point when it will go, it will have two kind of acceleration because there is a tangential as well as centripetal. Both accelerations will be there. So there will be always a net acceleration now. This is the net acceleration, and what they are saying is the angle between net acceleration and radius becomes 45 degree. I think they are talking of this angle because this is the radius, right? This is the acceleration, so this angle is 45. So direction between this radius and total acceleration, that has become 45 degrees. I think that is what they are talking about, the angle between total acceleration and direction along radius. Direction along radius means this direction. This is the direction of radius. Yes. Different direction means it is moving in a circle only, na? Circle only you have to take. Yeah, doesn't make. You take whichever way you want, but you need to take such that this centripetal means total acceleration must be making 45 degree with this. Okay. Yeah, circle means if it is going anti-clockwise, it is positive, and if it is going clockwise, it is negative. That is the direction plus minus. Okay. So now, when we solve what is the angular acceleration, they are asking alpha, they are asking. Hmm. Yes. Yeah, because yeah, they are equal basically. They are going to be equal 45, 45, right? That is what we can say that. Yeah. Yes. If they will be equal, then yeah, v square by radius is equal to r into alpha. Yes. Then alpha we can calculate from here as v square by r square. But did they give speed? Speed they have not given now because speed is changing, right? Speed is changing. We do not know what is speed in speed here. We do not know. Here, of course, speed was 0, so omega initial omega 1 was 0. Here, omega we do not know what is omega here. And what is speed means? Speed here we also do not know. I think we need to think of calculating that. Radius is given. This is vector addition now, because see, this is, suppose this is centripetal acceleration which is towards center, and this is tangential acceleration. The resultant of this is the diagonal. This is the net acceleration is diagonal. This angle is 45, right? So how do you calculate 45? Because in this is tangential, right? This is parallelogram. So this is tangential and this is tangential. And this is centripetal, so this is also centripetal. Okay, right? So tan of 45 degree, if you take tan of 45 degree is tangential by centripetal. Then 45 is 1, so they are equal, right? So alpha we have got. Then how to calculate? Yes, V we need to learn, because in the question only radius is given. They have not given speed at that moment. Okay, so think about it. Can we use the formula for constant alpha? We know formula, because tangential axis is constant means alpha is also going to be constant, right? Because tangential axes are alpha. So we can think of using omega equal to omega 2 equal to omega 1 plus alpha t. Those formulas we can try. Okay. Uh, yes, yes. So here this is omega 2 means final omega it is. So final omega is equal to initial omega. Let us say initial omega is 0 plus alpha into, let us say time spent is t. So that is what is t. So from here omega I can write as alpha into t. Then what else I can write? V I can calculate, because V is equal to omega r. V is equal to omega r. So omega is alpha t r. Okay. That V we can try to substitute it here. V by r is V by r is omega. So this is omega square basically. Yeah, this is omega square. So omega is alpha t then, correct? So omega is alpha. So you will be getting alpha square t square then, correct? Now we are getting because alpha will get cancelled now, correct? Uh, hmm. So alpha t will be coming as alpha t square will come as 1, correct? Alpha will get cancelled. Alpha t square will come as 1. Hmm, I think. Yeah, yeah, yeah. Yeah, yeah, I think they should give some information what time it happens, right? They must give. Might be time they should give, then we can calculate alpha. Okay, right, right. Okay, done. Okay, fine. Okay, then let us move next. Try this question. The particle moves clockwise in a circle of radius 1 meter with center 1, comma 0. It starts at rest at the origin at time 0. Its speed increases at the constant rate. How long does it take to travel halfway around the circle? What is the speed at that time? Okay, so first let us draw the origin x from y. Center is 1 comma 0 means this is the center 1 comma 0. radius is 1, so that means this circle will be like this. That is the circle. Then it is saying that it, its speed increases. It starts at rest at the origin. So it is starting at origin. Initially time 0 it was here. The speed increases at the constant rate of this. They have not said which direction. Oh, clockwise. They have given clockwise. So it is, yes, yes. So it is moving like this way. Okay. Here it is. Constant rate. Speed increases. That means tangential acceleration is given, right? Rate of change of speed they have given, that is pi by 2. Okay, radius is also 1. How long does it take to travel halfway around? Halfway means it will come here then, right? So how much that time will be there? This here to here time they are asking. So what time it will reach here? That is the question. Hmm. That means we know the angle, right? This angle rotated is 2 pi. Sorry, pi, right? 180 degree. Pi. So now the thing is that if you want to write as a sign, you can write it because everything is going clockwise. So all the motion will be in clockwise means clockwise you can, if you want you can write negative, or if you want you can write positive because sign convention is based on our choice, right? So we can, there is no such standard, but we can use. Finally, time will be always positive, right? Whether you choose sign convention this way or that way, time cannot come negative. So we can use the formula for alpha constant acceleration. So right, so tangential acceleration is r alpha. R is given as 1. So that means this is what is alpha. It's pi by 2. Okay, so then we can use angle displacement formula. Apply delta theta is omega 1 t plus half alpha t square over. Now we got it. If I take clockwise positive, then I will write this as pi only. Omega 1 is anyway 0. Half alpha we are going to take given as pi by 2 times square, then we calculate. So pi is equal to pi by 4 t square, pi cancel, t square is 4, so time is equal to 2 seconds, right? That's the answer, 2 seconds. Then what is the speed at that time? They are asking what is the speed. Calculate the speed at this time. So V equal to omega R you can calculate. Omega you calculate. Omega is equal to omega 1 plus alpha t that you calculate. Time now we know that. Omega 1 is 0. Alpha is already pi by 2. And time we know as 2. So that omega becomes pi. So now you calculate here. So V will become equal to omega into R. Omega has become pi. Radius is anyway 1. So that becomes pi meter per second. Correct? So these are very fundamental basic questions you can solve. Next. Figure shows the total acceleration and velocity of a particle moving clockwise in a circle of radius 2.5 meter at a given instant of time. At this instant, so we need to calculate at this particular instant. So at this particular instant, they are saying that the velocity is in this direction, and this is of course radius, and I think this is the total acceleration, right? Net acceleration is making 30 degree. That's what they are saying, right? Net acceleration. So total acceleration and velocity is like this. Radius is 2.5. V1 is 0.5. Radial acceleration means centripetal acceleration. Correct. This is centripetal they are asking. So we can just take the component now. I think the total acceleration is given as 25 only, right? This is 25 they have given. And this is the direction of radius making 30 degree. We can just resolve that. That's all. Right? No, no, no. That is total only, right? That acceleration A means total acceleration. Okay. So then we can resolve it. If suppose it is tangential, then you will use tan 30 degree to calculate. Suppose it is tangential, then tan 30 degrees tangential by radial. Then you can use tan theta. Okay. But I think here A means total acceleration. So then this you take 25 cos 30 degree. This will be centripetal acceleration. Tangential acceleration will be 25 sine 30 degree. That means half of that. 12.5 it will be, right? And this will be 12.5 root 3. Okay. This we can calculate. Speed of the particle. So tangential is the third part. So tangential we calculated, centripetal we calculated. Then speed of the particle we have to also calculate. What is the speed? Centripetal formula you apply, right? Centripetal is v square by radius, right? So v square becomes r into centripetal. Radius they have given as 2.5. Centripetal we have already calculated, 12.5 into root 3. So once you calculate this, you have to take under root of that. So under root of 2.5 into 12.5 into root 3. This calculation can be done. Clear? Yes. Yeah. So this is what it is. Questions are not tough, but we need to know the basic concept and then we can solve any type of questions, right? Yeah. See, basic questions are almost um, 60 to 70 questions are basic questions only. Huh? But in exam hall, it looks like tough only. Easy question also looks like tough. Tough questions, I will tell you, but these are basic questions we are first solving. Tough questions are also there. Okay, but let's solve first. Okay, now try this question and give the answer. We'll be winding up in a few minutes now. Okay, it is 11:30. Now we'll wind up. Okay. So you can solve this type of problems, right? Let us quickly solve this and then wind up this. So two particles A and B move anti-clockwise with the same speed in a circle of radius r and diametrically opposite at time 0. Is given a constant acceleration, tangential acceleration, and calculate the time in which equal. I think the same approach will apply, but one is going with the constant speed, another is having acceleration, right? Same approach we can apply now. Mhm. So apply the same approach. Let us solve them. So let us say from here we are starting. Time 0 is given constant acceleration. So one of the body is going with a constant acceleration. So some acceleration alpha they have given for this body. So alpha is not given tangential. So tangential acceleration is r alpha, right? So tangential acceleration is r alpha. So alpha is equal to tangential acceleration by r. So tangential divide by r, if you do 72 v square by 25 by r by r means r square will come. Okay, that is what it is. So that alpha we got it. So suppose, and this another one, this is A and this is B, they are going to hit somewhere. We do not know. Let us say it is hitting here. So this has traveled this angle theta B and it has traveled angle theta A. Whichever is small r, that doesn't matter, right? But theta B will be given clearly as omega into time, right? Because other is going with a constant speed, right? Opposite to each other speed. So that speed is v only. So omega will be omega into time. So omega is v by r into time. That is what is theta b, and theta a will be omega t plus half alpha t. So omega is same, right? Initial is same, omega t plus half alpha. Yes, yes. Oh, they are moving. Aha, they are moving from diametrically opposite. Okay, then diagram is wrong. Diagram corrected. That means here and here they are. Okay, A and B. Both are moving anti-clockwise. Anti-clockwise, both are moving anti-clockwise. So this way they are moving. Okay, this way they are moving. Right. So okay, then let us say that they are moving like this way, and A is having acceleration. So A has acceleration, B is not having acceleration. So let's say somewhere here they meet it. It doesn't matter. Let's say somewhere here they meet it. So both A and B will meet here. So here now what will happen? Suppose A travels angle theta A, then B will because this is pi already. This is pi, right? So B has to travel pi plus theta A. Correct? That is what is theta B. Okay. Then just change this little bit. So theta A, let us calculate because A is under acceleration. So that theta A we calculate first. So theta A is equal to omega t plus half alpha t square. Then theta B we will calculate as theta B is total angle, which is pi plus theta A. But theta B is calculated as omega into time, pi plus theta A. And this omega is V by R, speed is same. Okay. Pi plus theta. Theta now is substitute, so omega t plus half alpha t square. Okay. So I think this omega t, they are same omega t. They will get cancelled here, right? So this omega t get cancelled. So from here, um, but it is coming plus now. Time cannot be negative. The mistake is happening. Take that. Where it will might be in the diagram we are not taking proper, no? Diagram we are not taking proper. Anti-clockwise both are moving. Hmm. We'll use it, but the thing we'll put it afterwards. But the thing is that this equation we should not give. Maybe diagram we have to correct. Correct the diagram. So suppose I have taken uh, this. Let's take this as A, this as B. So B will be going slowly now. A is under acceleration, so A will catch it. Okay, I think this is the proper diagram. So let us say that B has moved this theta B and A has to move this angle, right? A will be moving this angle. A has to move this angle. Maybe this is correct, okay? And this is fine. Yeah, I think this is what it is. Correct. Because A is under acceleration. So theta A will be pi plus, I think interchange. Right, this interchanging we have to do. No, collision when happen both collides. It is so it is not a matter. Hmm. No. When collision happens, both collision happen. Both bodies collide. Okay. So who is first hitting? Because both are hitting at the same instant. Okay. Maybe somebody is hitting from behind. That is different thing, right? Behind it may be hitting. I think here A is hitting from behind, right? That's what it is. B is ahead and A is hitting from behind. Yeah, this is what it is. So now you take theta A is equal to pi plus theta B. So theta A is omega t plus half alpha t square is pi plus theta B is omega t. This will get cancelled, right? So from here now we will get alpha t square will become 2 pi and time we can calculate, right? Because alpha we know, calculate the time in which collision happens. So from here time we can calculate. So time square becomes 2 pi by alpha. Alpha now you substitute here. So 2 pi by alpha when you put, so 72 v square into 25, 25 pi r square v square. So here pi square, everything will come a perfect square root, I think. Check that, right? Because 2 will cancel with 36, 36. So t will come as 25 will come 5, pi square will come 5, r square will come r, 36 will come 6, v square will come v. This is the time. Uh, this is the time we will get. Once you get time, angle traced by, then you calculate angle traced by a theta a. Theta a we can substitute here, correct? Omega t plus half alpha t square or pi plus omega t, anything we can calculate. Theta a, velocity and radial accelerations. Radial acceleration means centripetal acceleration, because once you know v you can calculate v, omega you calculate. So omega at that place, omega, let us say omega to final omega, okay, omega plus alpha into t. So this omega of a we can calculate finally. So once you calculate omega, v of a at that instance is omega, final omega into radius. We can calculate this, right? Centripetal acceleration is omega square radius. So all calculations can be now done, right? Right? Okay, so done. So today we have discussed. Huh. Yeah, this is fundamental. Same, but proper diagram you draw, otherwise mistake can happen. Okay, that you have to put. Then work out questions. Okay, then we will see in the next class. Okay, fine. So thank you all. Bye bye all. Good night. Yeah. Good night.